Bond campus is set up a little bit differently than a standalone building. We have two main switch rooms like this on campus. This particular switch room is for building 4, so we're in building 4 now. Also building 2, which is business school. Also building 1, so MLC, the library, the arch area where the VC sits. So this switch room is looking after those 3 large buildings on the campus. So from this point, we've got that 415 volts coming from the substation that we just saw. So we could isolate all of the power coming into this room, or we can isolate individual buildings. You can see there's switches for each of the buildings. You'll also see that there's panels for the different plant equipment, so you'll see labels for air conditioning. And so think of each panel as a separate area of electrical supply, and we can isolate each of them from this point. We've got a couple of meters over here, so measuring the kilowatts of power that comes into this room. These are smart meters, so that means that they send data to the energy supplier through the internet. No one has to come to site and read the meter. So some of you might live somewhere that has an older meter, and every 3 months someone's knocking on your door wanting to read your meter. Yeah, so that eliminates the need for that. The benefit of these is also that facilities management here on campus, they can log into these through their computers, and they can look at real-time data, or they can trend log. So maybe a particularly hot day, they want to see how much more electricity we use than another day. But they can look at it minute by minute, hour by hour, day. They can break down that information. So these are really useful, and you can get so much more out of it than those old meters. You might have at home Wi-Fi too. So we have emergency power here on campus. We have a diesel emergency generator. It's located actually on the other side of campus behind the architecture building. But what we do have over here is the switch panel for it. So when the mains electricity supply gets cut off, this switch will automatically be triggered, and it'll send a message over to the generator to start up. Generator then supplies electricity back to here, which can be distributed through this main switchboard room. This one, it's not typical for a main switchboard room. It's a bit unique to Bond. This is a sub-switchboard that's looking after all the external lights on campus. So car parking, sports fields, footpaths, the ring, whatever we call this road that we have running through campus. All the lights are being controlled from this point. And we do have timers on here as well. So that will stop lights coming on during the middle of the day. So this tells, turn on at 6, turn off at 6. What they've also been installing on the actual lights themselves outside is daylight sensors. Now when Caitlin comes in and talks about lighting, she'll talk to you about daylight sensors, but what they're doing is measuring the amount of natural light that we have outside. And in summer in particular, when we have longer hours of light, that sensor will know that there's still plenty of light and stop the lights from turning on. So it means you don't have to keep adjusting the timer for different seasons. Or if you've got a particularly overcast day, you can allow the light to turn on a little bit sooner. So this room, we're in a fire-rated room. Did you all notice how heavy the door was? Fire-rated door, self-closing. It's very difficult to prop it open. So we're in this enclosed space. You can see some locations where some of the cable trays go through the walls. There's fabric and also foam is being used to seal up that gap around the cable tray. So it's fire-rated bags, that blue cloth that you can see up there, because we need to be in a sealed room. If a fire was to break out in this room, or maybe it was out in the hallway, we need to stop that spread of fire. This is a ventilated room, so we've got an exhaust point. Whoop, sorry, throwing my pen around. We have an exhaust point up there in the corner. And then our air supply for this space is actually just coming through from the hallway. Okay, so as air gets drawn out there, it's just causing air to flow in this way. And this is quite cool air. It can get quite hot in here. This has a fire shutter on it. So in a fire event, these shutters will close down to fire rate this opening. Now, does anyone know what these solid cable trays are called? Did Caitlin talk about them in Electrical Week, and do you remember what they were called? So we've got two different types of cable trays in here. We've got these solid ones, these dark grey ones, and then this is a cable tray as well, this open steel work that you can see. So this is called a busway. Has bus bars inside it. This is considered a permanent connection or a rigid connection. So it means it's very difficult to move it around if you wanted to. We usually use these to connect the main switch room with plant rooms. So where we want to transfer 415 volts to rooms. So when you go back out in the hallway, you'll see these travelling through into the mechanical plant room. So inside there is flat copper plates, and it's those copper plates that transfer the electricity. The open cable trays that are here, they're a flexible connection. It's quite easy if we need to redirect one of these cables. It's very easy to do when they're set up in this arrangement. We do have a BS2 smoke detection system in here, but there's so many pipes that it's quite difficult to point out exactly which one is BS2. So when we get into the communication room, we'll talk more about the BS2 system. Okay. I'll move over to the UPS room, but take some photos in here and then wander